Generics are a tool to write polymorphic code in TypeScript. It's a little bit difficult to get your head around generics if you're coming from a dynamically typed programming language such as JavaScript. They help you write polymorphic functions which are dynamic but strictly typed. I'm going to tell you what are generics. We'll keep it very quick and short. So let's put our attention to Visual Studio Code and start writing some code which is generic in nature. So for the sake of our example, I'm going to declare a function over here. Let's call this function as return param. And this function would take in one parameter, which is the param itself, and is going to return that parameter. This is a very simple function which just takes in a parameter and returns the same parameter from the function itself. You will see that over here, TypeScript is complaining me because this particular function, the parameter is of any type. And that's a problem in TypeScript. We have to avoid any types. That's the whole purpose of using TypeScript. What you see on your screen right now is a default JavaScript behavior. So if I hover my mouse over return param function, you will see that TypeScript correctly infers this as parameter of any type and even the return type of any type. But over here, if you think about it, this function actually takes in any type and returns any type. So TypeScript is not wrong over here. But the problem is that TypeScript is not aware of what type of value I will use in order to invoke this function. So for example, I can use a string in order to invoke this function. I can use a number. And when I'm invoking this function, TypeScript is not aware of it. So is there a way to actually strictly type this kind of a function and yet making TypeScript aware of the type of value that we would be using as an argument for this function? That's where generics come in. Let's go ahead and declare a new type alias, which is going to be of a generic type. So here I'm going to declare a new type alias, and let's call this as a return param, which is just a function call signature as of now. If I have to match this function call signature to this particular function, this function needs to take one parameter, which is the param itself. Now, how do we strictly type this? How do we type it in such a way so that any kind of type can be used with this kind of a type alias, and yet TypeScript is aware of the kind of type that we'll be using in order to invoke such a function? For doing that, I'm going to declare a generic variable. A generic variable can be declared between these two angle brackets. So just before the function body or the call signature, I'm going to declare a generic variable, and let's call this variable as type. You can call this variable anything. Consider this generic variable as a variable of type. So if this function was supposed to be invoked with a string value, this is of string type. If had it been a number, it is of number type. So this is a variable assigned to the type of value that would be used in order to invoke this function. Now, since we have declared this function over here, we can use this function anywhere in the call signature. I can always say that param is going to be of the type, that is the variable that we have declared. So essentially what I'm saying is that if string is used, then parameter is of the type string. And if parameter is of the type or string or number or whatever value you assign to this variable, then the outcome of this function is going to be of the same type. This is a generic type alias. Now we can use this return param type alias for this particular return param function that we have declared. So I'm going to use return param like so. Now we can see the magic. TypeScript now understands that return param is a function that takes in a type which is a generic, and the output of that type is also the type itself. Now we can test out the return param function. We can invoke it with a string value or a number value and test it out. So let's go ahead and do this. I'm going to go ahead and declare a variable over here called string output, and the string output variable is going to have a value where I'll invoke the return param function. Now, since I want string as an output, what I can say is within the angular brackets, I can typecast and tell TypeScript that, look, I'm going to use a string in order to invoke this function. And since TypeScript now knows that I'm going to use string in order to invoke this function and pass it as an argument, I can pass a string as an argument to function, and TypeScript will not complain. In fact, you will now see that TypeScript understands that string output is finally going to be an output type of string. If I hover my mouse over the return param function as well, you will see that TypeScript has replaced the generic with a string. TypeScript understands that we are using return param with a string in this particular case. Return param still remains a dynamic function, but now it is strictly typed. The outcome of this function is also well known now. Where earlier we were using any type as a param and any type as the outcome of this function, we are now strictly typing it and saying that this function is going to return a type of a string and is invoked with an argument of string as well. Now it turns out that you can invoke this function without explicitly typecasting like the way we have done over here for string value. We can try this out with a number without typecasting. In order to do that, let's go ahead and let's declare another variable called number output, and then invoked the return param function with a value which is a number as of now. In this case, if I hover my mouse over return param, you will see that now TypeScript infers that the value that is used as a generic is an actual type of 123. It's a literal value of 123 and not a number which we had in our previous case. Also, we are not typecasting it this time. TypeScript is doing this inference for us. We are not typecasting a string value or a number value like this before invoking this function. The beauty of this is that if you look at number output, TypeScript now understands that the final value that would be returned by this function is of the type number. TypeScript assigns it as a final value of number and not as 123 because we have used let keyword in order to declare this particular variable. Had I used the const keyword, this would have been a literal type of 123. I can show this to you. So let's change let to const, and in this case you will see that number output now becomes a literal value of 123. So TypeScript over here now understands that the final output is going to be 123 and nothing else. This is because constants in JavaScript cannot be reassigned. Let's look at one more example before we jump on to the next concept in generics. This time, I'm going to declare a new variable, and this is for an array output this time. Again, I'll invoke the return param function, and this return param function will have an array of numbers. Even though array of numbers has value of 1, 2, and 3, but you will see that array output is an array of numbers, and even the return param, the generic inferred by TypeScript over here, is an array of numbers and not a literal value of array of 1, 2, 3 or a tuple of 1, 2, 3. This is because TypeScript understands that arrays are mutable in JavaScript and any other value can be used over here. The position where you declare your generic variables really matters. So had this generic variable been declared before the equal to sign, then it would have meant something else in TypeScript. Let's look at an example of what this kind of a declaration would mean. So what I'm going to do is I'm going to declare another type alias. I'm going to call it return specific this time. And this is again going to be a function called signature. Now, this time I'm going to declare the generic right before the equal to sign. This is still a generic variable. You can name it the way you want to. The naming convention in TypeScript world starts the generic with T. So you would usually declare your generic variables as T, U, V, X, and so on. Just like the type generic we had declared over here, we can use this T generic variable as well. So parameter is going to be a type of T and the return output is going to be a type of T as well. But this declaration of generic function is very different from this kind of a declaration. When you declare generics like this, where the generic is before the equal to sign, TypeScript now expects you to declare the generic when you're defining the function. Let me show you what I mean by this. So for the sake of our example, let's declare a new constant, and this is going to be a function, and where you take in parameter and return the parameter itself. This function is same as this particular function that we have here. But this time, instead of assigning it a type of return param, I'm going to assign it a type of return specific. So let's go ahead and assign it a type of return specific. You see, it just does not work. TypeScript is complaining over here. TypeScript says that generic type return specific requires one type argument. So it is expecting you to declare what kind of type you would be using in order to invoke this function. Here, TypeScript is not going to do the inference for you. It expects you to write a different function for every type. So if you're writing a specific function for string, then you will have to declare the type well in advance. If it's a function for number, then you would have to declare the number type well in advance. Even though the signature of the function remains the same, where you take in a parameter and you return a parameter, but TypeScript now forces the developers to write different or separate functions for each of the types. So when you want your developers to write different functions for different types, this is the kind of syntax you can use. So here, since the function returns a number, I'm going to pass or typecast a generic saying that this function is going to be just for numbers. Now TypeScript understands that this function is just for numbers, and similarly using this particular type alias itself, you can declare function for other types also. Let me try to declare a function for string using this particular type alias. So let's go ahead and declare this function once again. And this time the function is going to be return string, which still uses return specific as the type alias. And then this function signature remains the same. You take in a parameter and return the parameter. Here, I'm going to typecast this and say that this function is for strings. Now, return string just becomes a function which is only available for string arguments. We can try invoking the return number function and you will see that it only works for numbers. So if I try passing an argument of string, TypeScript is going to complain and say that this particular function is just for numbers. Even though return string and return number are using the same type alias, that is return specific, but they are dynamic in the sense that you are declaring the type of generic variable while declaring the function. So they become specifically for number and strings respectively. Now, if I change this to a number value, TypeScript will not have a problem. On a side note, I do have a course on TypeScript, and this course covers all beginner as well as advanced level topics in TypeScript. So starting from the beginner level concepts like arrays, tuples, objects, primitive types, I take you to advanced level concepts like declaration files, namespaces, modules, generics, decorators, and so on. This course has more than 240 videos with more than 22 hours of content. I also show you how you can use TypeScript along with Node as well as with React. The price is pretty nominal and you can check out the course as the link to the course has been given in the description below. That's all for this video. I'll see you soon, guys. Thanks for watching.